Hello everyone, welcome to the World Drone Market channel. Today, I'm going to show you how to assemble a drone. In the previous video, I explained how to install the flight controller, GPS, and remote control receiver. This video is the final step in assembling a drone, which involves debugging the flight controller through a computer ground station and conducting a flight test. Let's see how it's done. Connect the USB cable to the USB port of the flight controller and then to the computer. Here, we can use Mission Planner software or QGC software to debug the flight controller. Taking Mission Planner as an example, after entering the software, the first step is to download the firmware. Do not click Connect yet. Instead, click Setup and then Install Firmware. Since the 450 frame is a quadcopter, I'll choose the multi-rotor firmware. If you're using a different model, such as plain firmware for fixed-wing aircraft, please select the corresponding firmware. The firmware settings and parameters will vary depending on the model, so adjustments need to be made based on actual conditions. Sometimes, the firmware may not upload successfully, so multiple attempts may be required. After downloading the firmware, connect to the ground station. Once connected, select the frame type. Click Mandatory Hardware on the left column and select Frame Type below it. This step is to choose the type of multi-rotor. Since we're using a quadcopter frame, we'll select the quadcopter frame. After choosing the type of the frame, we can turn off the internal safety switch first, because we haven't finished debugging many steps of the frame at the beginning and the frame will make a noise. So we can temporarily shield the sound. Click Config on the top left corner and find Full Parameter List on the left column. In the box under Search on the right column, enter the parameter for the safety switch. Then change 1 to 0 and click Write Params on the right column. Move to the Data page and click Actions. Select the parameters shown in the video in the first box. This step is to reconnect the flight controller and refresh its parameters. Please note that in order to make the new parameters take effect, you must refresh the page after modifying them. You can refresh the page after modifying one parameter or after modifying multiple parameters. After completing all these steps, proceed to accelerometer calibration. Click Setup on the top left corner and find Excel Calibration on the left column. Click the first green box on the new page and follow the prompts to calibrate. Place the drone with the nose facing forward and then position the frame according to the required directions. Click when done after each action until the prompt displays Calibration Successful, indicating that the accelerometer calibration is complete. Next is compass calibration. Click Compass on the left column. Since we have an external compass, there are two compasses displayed. If you don't have an external GPS, there will only be one compass built into the flight controller. Click Start on the page and swing the drone in all directions as shown in the video until both progress bars are full and you see the prompt, "Please reboot the autopilot." The compass calibration is now complete. This process may not succeed on the first try, so you may need to adjust it several times until you see the prompt, "Please reboot the autopilot." Now let's calibrate the remote control. Find Radio Calibration on the left column and click Calibration Radio. When we move the joystick or buttons on the remote control, the corresponding channels will show fluctuating values. At the same time, when moving the joystick, levers, or buttons, the corresponding channel values change. indicating that the channel number of that joystick, lever, or button is displayed on Mission Planner. For example, when we move the joystick in the upper left corner, the channel 5 value changes, indicating that this joystick uses channel 5. After moving all channels, click when done. The remote control calibration is now complete. After completing the accelerometer calibration, compass calibration, and remote control calibration, reconnect the flight controller and refresh its parameters. Now, let's proceed to the last two steps of assembly and debugging, which are setting the flight mode and return to home channel. First, let's set the flight mode. Click Setup and select Flight Modes in the left column. Since the default channel for flight mode is channel 5, we can find channel 5 on the remote controller by adjusting the joystick on the remote controller calibration page. The channel for flight mode can be changed to other channels, but here we'll use channel 5 as an example. Channel 5 is a 3-position joystick, so it can switch between 3 flight modes. Every time we adjust the joystick to a different position, it will jump to the corresponding box. At this time, the box on the Mission Planner will turn green, indicating that the position we adjusted corresponds to this channel. Inside the box, we can set corresponding flight modes for each position. Here, we set Stabilize, Alt-Hold, and Loiter. After setting up, click Save. In the flight interface, we can see that when we adjust channel 5, we can switch between the flight modes we just set. Next, let's set up the Return to Home function. The channel for Return to Home mode is also customizable. Taking the joystick in the upper right corner as an example, in the remote controller calibration interface, we can see that it's channel 6 when we adjust the joystick. We go to the parameter table and search for the RC6 parameter. If you choose channel 7, then search for RC7 accordingly. Then, find the parameter in the video, click on the value in the 5th column, and we can set the desired function for this channel. Since we want to set up Return to Home, click on RTL and write the parameter. In the flight interface, adjust channel 6 to see the Return to Home mode switch. The assembly and debugging are complete. Now, let's connect the remote controller to QGC. We turn on the remote controller and open the TX software. In the new page, select Data Link and then Connection. There are multiple data transmission connection methods, but let's use UDP as an example and select UDP. Go back to the previous page. Since we're using an open source flight controller, select Customize in Flight Controller. Return to the previous page and select 57600 in baud rate. The baud rate for UDP mode is defaulted to 57600. Then, go back to the main page, click on the QGC software. And click on the top left corner. In the new pop-up window, select Application Settings and click on COM Links in the left column. Click Add at the bottom of the screen. In the new pop-up window, under the Name column, you can give this setting any name you want. Here, we're using the MK15 remote controller, so we'll use MK15 as the name. Scroll down and select UDP in the Type column. Scroll down further and enter 19856 in the Port column. In the box below it, enter the website address. These settings are based on the instructions, and the website address will be provided in the video description. Click OK to connect. After the connection is completed, we tried to unlock it and succeeded. The motor is rotating. That's it for the aircraft's assembly and debugging. Next, we'll take the assembled aircraft outdoors for testing. First, let the aircraft take off. Switch to the loiter mode, perform a 360-degree spin, and fly forward, backward, left, and right to test the overall stability of the aircraft. Then, fly out to a considerable distance. Adjust the 6th channel we set, switch to the return to home mode, and let the aircraft automatically and safely land at the starting point. The testing is complete. That's all for this episode. Thank you for watching. Stay tuned for more content.